Okay, so when we talk about, I'll call it general trig, there are 5 main question types. So I'll just quickly go over, because maybe some question types you feel quite comfortable with, other ones you might need a bit of extra help, and it's helpful to know what that is. The one is calculating the value of an expression without using a calculator. So this normally involves like a diagram, either on the Cartesian plane or a freestanding triangle. And it's normally going to involve things called special triangles to evaluate. And we will see those later today. Then there's also express trig ratio in terms of the given variable. And there's also simplify trig expression. So that will often involve things like you've got sine of 180 plus x. Do you realize that 180 plus x is in quadrant 3? In which case, in quadrant 3, tell me in the chat, is sine positive or negative in quadrant 3? Put your answer in the chat. Okay, so sine is only positive in quadrant 1 and quadrant 2. So that's quadrant 1, 2, 3, and 4. And so in this quadrant, sine will be negative. And since we always ask ourselves, how far is it from the nearest horizontal, that would be the equivalent of minus sine x. So you have to know what's called the trig reduction formulas and the trig co-ratio formulas to reduce big angles to smaller ones to simplify. So these are, you're definitely going to get questions like that in your trig part of paper 2. Then the other types are prove an identity, in which case you're normally going to work with the left-hand side or with the right-hand side separately and keep changing them using trig identities. So the main trig identities would be something like that, something like that, and then you can also use the normal like identities, like the sine of 90 minus x is cos x, that's a co-ratio, or the sine of 180 minus x is the same as the sine of x. So you'll work with either side and try and show that the one side is equal to the other. Give me a thumbs up if you've recognized all those question types so far in terms of the trig revision. Just give me a thumbs up if that's all looking, I'm not saying you know it, but you're like, okay, I know what ballpark we're playing in today when we start our revision. So that's good. Then the other type of trig question which we want to go over is some basic solving a trig equation. So I'll just give you an example. If I say to you the sine of x is equal to 0.3, and I say find the general solution to that, I'll just say GS. Or I could say something like, here's the cos of x equals minus 0.3. Find me the general solution to that. You need to be comfortable with the following ideas. So when we taught this in class, we taught it as step 1, ignore if there's a negative there. Now there's a positive, so it doesn't matter. And your first step is to find your reference angle. So tell me, on your calculators, if you go shift sine 0.3, what do you get? Tell me in the chat what you get if you do that. And then welcome to, I see Akwande's joined us, Ganlin, Livu, Njabulo, Siamtanda, Tamia, and Tandiwe. Welcome, everyone. Okay, so our reference angle is 17.46 degrees. The second step in our process, if you go back to the videos, is to ask ourselves, in what quadrant is sine positive? And it's positive in this quadrant and that quadrant. And in this quadrant, the answer would just be the actual reference angle. And in this quadrant, the answer will be 180 minus the reference angle. And then step 3 would be just to write the general solution, which would be x is equal to 17.46, or x is equal to 180 minus 17.46. So let's go 180 minus 17.46, and that gives me 162.54. But I've left something out. In order for this to be a general solution, I need to add something in. Would anybody like to tell me what I need to add in still? Who is going to share their knowledge and wisdom with our online maths family? In order for this to be a general solution, I have to, thank you, Callan. There's a k times the period of the graph, in which case the sine graph is just 360. And we say that k can be any integer. So that would be an example of a trig equation where you have a general solution, and I've gone through the 3-step process. Give me a thumbs up if that looks somewhat familiar to you. Give me a thumbs down if you're like, whoa, 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 but I need a bit more. You need to show me a bit more detail here. Okay, don't worry. We're going to do a second example now. So the second general solution question we're going to solve is the cos of x is minus 0.3. Now, there's something really important. When you find your reference angle and you use this method, you ignore the negative. So the negative we will deal with in step 2, which is the quadrants. We don't deal with the negative in step 1. So can you please tell me the reference angle that you get by going shift, or you can go cos to the minus 1 or shift cos, and only use the 0.3. What do you get for your reference angle for the second trig equation? I'm just going to get rid of this first one because it's taking up a bit much space. Okay, so what I'm seeing in the chat is 72.54. Awesome. Okay, now step 2. In what quadrants is cos negative? I'll give you a hint. Which quadrants? Because at the beginning, this said cos is negative 0.3. In which quadrants does this? So everything's positive here. Cos is positive there. I must be in quadrants 2 and 3. And in quadrants 2, the answer will always be 180 minus the reference angle. And in quadrant 3, it'll always be 180 plus the reference angle. So now, how do we get our answer? And I remember in class, what I was actually doing is I was writing, look, there are 2 sets of solutions here. It's going to be the quadrant 2 and the quadrant 3 solution. So x is going to be equal to, now I need to go 180 minus the reference angle. So I'm going to get for my first answer 180 minus 72.54, which is 107.46, or x is going to be equal to what else? What's going to be the second solution? What's going to be the second solution that I deal with when I do this? So because it's in quadrant 3, it's going to be 180 plus 72.54, and I'm going to get 252.54. And again, because the period of the cos graph is 360, and it's a cos equation, I'm going to add k times 360 and k times 360, where k is an element of the integers. Now, we're going to do practice questions from old exams, but just give me a thumbs up if solving a trig equation for a general solution where the number is negative is okay for you. It's actually not that bad once you get into the habit of doing these. Now, what happens also is that these equations get connected to graphs, but we'll deal with that in upcoming lessons as we go. Okay, so we've had a look at the big 5 of the trig, general trig questions. Let's have a look at just some other theory that goes with this. So this is just, I'm just going to remind you of this. The basic stuff from trig is we always need to know about sine, cos, and tan, and that's in a normal, I call this a freestanding triangle. But you also need to know about SOHCAHTOA in terms of the quadrants, in which case you replace the y, the O with the Y, so I think of the word yo, and then the H is always the R, and then I think of the word ax, for A replaces X. So you just think yo ax, and then you're good to know the H is the R, Y, and X. So you need to understand that there are two different definitions that can be used, but they're actually equivalent. It's just this is the freestanding, whereas this one is the quadrant definition. Give me a thumbs up if your theory is okay. This over here is the reference angle. Okay, it's good just to do a little top up of our theory knowledge. Then, as we look back, we have some things called special triangles. You need to just memorize these, and then you write them down. When you use them, you can just write them down on the page. And so that's something which you get used to. You also can, there's special triangles at those, like the sine of 90. But the sine of 90 you can just get from the sine graph. So like if you imagine, you know the sine graph, the sine of 90 will just get up to 1. But you can kind of check this on your calculator, but you do need to know how to evaluate the angles that fall on the corners. So like here's the 90-degree angle, here's the 180, there's the 270. But your calculator can help you out, but you're meant to show some evidence that you understand where it came from. Okay, special triangles. And then you also need to know where the quadrants are positive and where they're negative. And this thing called the cos diagram. So cos is positive here, everything is positive there, sine is positive here, and tan is positive here. And if you're not positive, you must be negative. So in quadrant 3, sine and cos will be negative. You also need to know that all angles in this quadrant are just going to be the reference angle, or theta, 180 minus here, 180 plus here, 360 minus. You also need to know about the fact that angles here are going to be 90 plus theta. Over here, they would be, this would be 270 minus theta, 270 plus theta, and this could be 90 minus theta. That's just for what we call the co-ratios. So when we talk about the reduction formula, we think about the horizontal axes, which are 180 and 360. When we think about co-ratios, we think about the vertical axes, which are at 90 and 270, as opposed to 180 and 360. And these give rise to the reduction formulas here. Give me a thumbs up if this theory is looking familiar. Thumbs down if you're feeling a bit unsure. Just to check your reduction formula knowledge, if I say to you, what is 360 plus theta, could you reduce that for me? Will it be positive or negative? And can you reduce that for me? So these are the little skills you need to be comfortable with. What quadrant am I going to be in if I'm 360 plus theta? Well, 360 plus theta is actually back in quadrant 1, and the nearest horizontal axis is going to be here. So this is going to be plus sine theta. What if I said to you, what is the cos of 360 plus theta? What would you get for that? Same thing, huh? It would be that. Now you need to go over this and just make sure there are many variations, but they'll come up in the questions we do today. So that's there. And then these are some more trig identities. So tan is sine over cos. And then this is called the square identity, but you can also rewrite it so that you get sine by itself, or you can rewrite it so that you get cos by itself. And this often comes up in trig identities, being able to rewrite things in different ways so that you can make the left-hand side equal to the right-hand side. Okay, and then this is an example of using co-ratios. So again, if you struggle with this, I would even pause the video if you're watching the recording, or come back to it later and just check that you understand how this is happening. And then this is the process that I was telling you about earlier on, and I showed you about finding the solution to trig equations. Okay. Let us just quickly check a few important ideas about our understanding of trig. I want you to, let's have a look here. If I tell you that the MP is 13 and MP is 5, I want you to tell me what is the cos of alpha equal to. So think about what you know about trig, think about what you can use to help you, and work out for me what is the cos of alpha. And I'd love a question. If I'm going too fast or you'd like to clarify, tell me what you think that is going to be. And I'll say this, you're not allowed to use a calculator. So what I'm going to do is I'm going to write in, if alpha is the angle, that's going to be O, that's going to be H, that is going to be A. So cos is A over H. So it's 5 over 13, which is the same as 0.38. But I would just leave it as that. Next part of the question, what is the cos of beta going to be equal to? And you're not allowed to use your calculator. You have to use, well, you've got to solve this problem for me. What do I need to figure out to help me? I feel a bit stuck. Who can help me find my way? Give me a tip. Help me see, there's something I have to do before my life gets easy. Thank you, Pafunzo, for your generosity. MN is unknown. Pafunzo, how would you find MN? What tool would you use? Pythagoras, yes, absolutely. So MN is equal to 13 squared minus 5 squared over that. Now work out what the answer to that is, and then tell me what the cos of B is in the chat. So I get that is 12. So we know that this is 12. What is the cos of beta going to be? Now, what's sneaky about this question is the A and H and O do not stay in the same place. If you change your reference angle, the names of the things opposite also have to change. The hypotenuse stays in the same place, but the A is in a different place. So now the cos of beta is going to be 12 over 13. And a lot of students struggle with this idea when you change the angle of the reference angle, that the O's and the H's and the A's move around, or the X's, the Y's, and the R's move around. Thumbs up if I've helped you understand that a bit. Thumbs down if you feel a bit lost about what I mean by the O's, A's, and H's moving around. Okay, so this wouldn't be out of place in an exam question here. Let's keep moving. All right. I want to know if the tan of theta is less than naught and the cos of theta is less than naught, then which of these statements is true? If you know the tan of theta is less than naught and the cos of theta is less than naught, then is theta between naught and 90? Is it between 90 and 180? I want you to vote. Which option? What tool would you use to even help you? Okay. I was thinking I need the cost diagram to help me. So tan is negative. Where is tan negative? I think tan is negative here and here. Where is cos negative? Not here. Cos is negative there and there. So what quadrant do I need to be in? I think I need to be in this quadrant. Oh, let me use my highlighter. I need to be in that quadrant. Well, since this is 90 over here, so since this is 90 and that's 180, I think it's between 90 and 180, which is B. And so the correct answer is B. Okay, next question. Tell me, is the cos of minus 215 positive or negative? And don't use your calculator. I want you to work it out using just the cost diagram. Is the cos of minus 215 positive or negative? Now, negative angles go the opposite direction. This is the positive direction. For negative angles, you go that direction. Now, I wonder if that's going to have an effect on it being positive or negative. Okay, I'm going to go in this direction. So here's naught, here's minus 90, here's minus 180. So my angle for minus 215 is going to be in this quadrant here. Now I'm going to put in what we call the cost diagram. Is cos positive in quadrant 2 or is it negative? So the cos of an angle, is it positive or negative in quadrant 2? It's negative. Yeah, so watch out. The cos of minus 215 is going to be negative. So that's a sneaky one, because you need to know that it goes the opposite direction. Okay, what is going to be the sine of 315? Is the sine of 315 going to be positive or negative? So now it's a positive angle, so I need to go in this direction. That's 180. And that's 270. Now I've still got to go a little bit further, so I'm in this quadrant. So it must be negative. Let's try one more thing, because I want to test your knowledge. What if I said to you, what is the following? The tan of minus 120. Is that positive or negative? Is that going to end up being positive or negative? Now remember what direction the negative angles go. Do you think it's going to be positive or negative? So we go minus 90, minus 120. So we're in this quadrant, but, oh, wrong thing. We know that in that quadrant, tan is positive. So that just helps you get a little bit more oriented with negative and positive angles. Okay. Give me a thumbs up if you feel like you understand negative and positive angles, depending on what quadrant you're in. Okay, so we're doing a nice little bit of revision tonight. We're just getting those trigonometry juices flowing here. So let's go and look at a question like this. These are also very typical exam questions. Given that the tan of theta is minus root 3 and theta is between 180 and 360, determine using a diagram the value of, and it starts with the sine of theta. Now, I want you all to draw a diagram for this information. And when you have drawn your diagram, I want you to say done. So draw a diagram. I'm going to get some water. And when you've drawn your diagram, I want you to say done. Okay, let's draw some diagrams. There's two types of diagrams you could draw. I think probably the best one is to draw it on the cast diagram somewhere. And since tan is negative, we have to think about this. Where is tan negative? Tan is negative in quadrant here and quadrant there. Where is 180 and 360 between? Here and here. So you know what? My drawing, my triangle, needs to be in that quadrant. Now, what I want you to do next, I've helped you figure out what quadrant your triangle is in, but I want you to figure out what values go on my triangle, because this triangle is going to help me solve these two questions. How do we know what to label the sides of this triangle? I'll give you a hint. You can write this over 1 and it doesn't change anything. So how can you use those two things? Now this is tan, so I think the tan of theta can be written as y over x, in which case it can be written as minus root 3 over 1. Although that minus sign, it could be on the top or the bottom. Okay. Now, if I look at my drawing here, x is positive. So that's going to be 1. The negative is going to stay here. And this would be negative root 3. Give me a thumbs up if you understand how I took this information, found the quadrant, and then took this and put that in. Now, a lot of you won't understand that. That's fine. That's why I'm doing this. I want you to figure out for me, what is this unknown side over here? What is this unknown side over here going to be? Can you work it out? I'll give you a hint. You use Pythagoras. We'll call it R. We'll say R is equal to, and I want you to work out what R is going to be equal to. So it's going to be 1 squared plus minus root 3 squared. And we seem to get 2. And the R value, oh, let me bring that back. The R value of 2 is just going to go here. Okay, now, given what you know about the diagram, without using a calculator and by reading off the diagram, what is the sine of theta going to be equal to? So using this triangle, because it said using the diagram, what am I going to get the sine of theta equal to being? So Machidisa was asked, how do I know what quadrant? So you use this process of elimination. So at the very beginning, it said tan was minus root 3. And you know from the cast diagram that tan is only negative here and here. But it also says theta is between 180 and 360. And then it must be in one of these two. And because the only quadrant that has 2 ticks, that's why I drew my triangle there. Does that help, Machadiso? Fantastic. Thank you for your question. Now, for the sine of theta, let's go to my little thing here. It's y over r. So what is y? Well, y was minus root 3, because that's the y bit over here, right? That's the y. And then r, well, r was the stuff that you just worked out, which was 2. So that was like this part over here. So that is the answer to A. I want you to work out for me using the drawing, what is the value of 3 cos theta? So that was A, and this was B. So B, I've got a 3, but now cos is x over r, or A over h. So x over r, well, what is x? X is 1, and r was 2. So you just get 3 over 2. So it's not going to be root 3. It's literally just 3 over 2. Yeah. That's it. Okay, so if you think about what we've done in this first half of the lesson, we've looked at revising the basic ideas for general trig, and we've started to connect trigonometry to the Cartesian plane and just playing with questions like that. We need to take a break now, so I want everyone to step away from their tables or beds or chairs or wherever it is you find yourself, and I want you to join me in just taking care of your brain. If you overwork your brain too much, it's not going to be nice to you in the second half of the lesson. So take care of your brain. And the best way I know to do this is to take care of your body, because they're connected to your brain. What's connected to your brain. So first step on our break is to breathe in deeply through your nose and breathe out again. And then hold your breath a little bit in the process. So breathe in. And it floods your body with oxygen. So breathe in. Breathe in. Breathe in. Okay, so my body feels like it's getting oxygen, which is helping my brain unwind and repair. And so let's then get some circulation in our body. And so we're just going to get nice and loose. So we're going to shake our arms around a little bit, like they're like hardly connected on a string. Shake out your legs, give them a good shake. You want to feel your body really just loosening up. You don't want to be holding any tension. Okay, then we're just going to roll our shoulders. Often your shoulders will tighten when you're stressed or you're feeling tight. So just roll your shoulders back, loosen your jaw, and then roll your shoulders forward as well. Oh, I can feel I'm feeling nice and relaxed. Okay, so we've got some circulation and we've relaxed. We've got some oxygen. Last thing is blood flow or circulation. And so the jumping jack is what we use to send the blood around our body. We'll start in 3, 2, 1. Let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and just take 30 seconds for yourself. I must be honest, I feel like my concentration has improved. Let me know in the chat if you feel like my 3-step process is good for concentration, or if you feel like, yeah, I'm a bit like this doesn't really do it for me. I'm curious to know what it feels like out there. I can feel my heart rate's still jumping though. Whew. Okay, but that's a good thing. All right, so now let us do another question like that, because I feel like we just need to keep getting this right. So I want you to try and solve this question for me by yourself. This is normally one of the first questions you'd get in your trig exam for general trig or in paper 2. So I will give you 2 or 3 minutes to do this. And then just tell me in the chat done when you're done with the drawing. So how can you use this information where p is less than 0 and that information somehow that is to help you figure out what quadrant you're in? So if p is negative or less than 0, cos must be negative. Where is cos negative? Here and here. It also says b is between 180 and 360, which is here and here, which gives it away. The triangle must be here. Now, we need to, it says, determine using a diagram and an expression in terms of p. So we need our SOHCAHTOA again to help us out, because otherwise it's going to be confusing. So yo for that part, x for that part, yo, and x. Now, if the cos of beta, cos is x over r, or in this case, the cos of beta, so cos of beta is going to be x over r, which is the same as p over root 5. So now, where there's an x, okay, this is going to be, and it said p was less than 0, so that makes sense, because look at the direction. So that's p, and p is going to be negative. And then r has to be root 5. Now, we're going to have to find what this length is, the y, in terms of p. So that's a little bit more tricky. How am I going to do that? Well, I'm going to say square root 5 squared is equal to y squared plus p squared, and that's by Pythagoras. Give me a thumbs up if that makes sense to you. Now, the problem I have now is I need to get this y by itself. So what I'm going to do is, the good news is when I square this, I just get 5. And I bring the p squared, I get that. And then if I square root both sides, my y value is actually going to be the square root of 5 minus p squared. So that was quite a lot of maths all at once. Another thumbs up if you followed that, thumbs down if you didn't. Okay, now, you guys and girls need to tell me, what is the tan of beta in terms of P? What is the tan of beta in terms of P? No. To remember, tan is y over x. So if that's y over x, what does this need to be? Okay, it's a bit of a mouthful. The top bit is going to be 5 minus p squared. And on the bottom, I'm going to have p. So I'm just pulling straight out of the triangle. So like y is this one. Whereas the x is that one. Okay, what is this going to evaluate to? So I've done A for you. Can you work out what B is going to be? What does it evaluate to using this triangle? Oh, P is negative, yes. Oh, okay. So because the P, it is negative, but it's a variable, right? So you don't know, P could be -3 or -5. So we've just left it because it's a variable. It can hold a negative value. Okay, does that make sense? All right, so for this one here, all I'm going to do is say cos is, what is cos? Cos is x over r. So I've got x over r, but it's x over r squared. So another way of saying that would be just like that, minus 1, in which case we go 2, and then what was x? X was just p, and r was just this horrible thing over here. And then I've got a minus 1 down here. But now the last bit is I go 2. Well, I need to square this whole thing here. So I get 2p squared over 5 minus p squared minus 1. Ugh. It's a bit of a mess, but all I want to say to you is this bit is the cos bit. So that's the cos bit in here. The rest of the stuff is just coming from the triangle. I'm scared I might be giving some of you a fright, but I just want to sort of demystify it. Give me a score out of 10 for how you're feeling about this question. I know a lot of you will find it hard, but we're just get back in the swing of things here. Reniwe, let's go to you.
Hi, sir.
Hey.
In B, why
Yes.
is it p over the square root of 5 minus p squared?
Oh,
Because
I made a mistake.
yeah.
Sorry. Really, thank you so much. I see my mistake now. You know what it is? I think that my screen got too busy. So R is root 5. Now I know why so many people are confused. Okay, so now if I square this, I get 2p squared over 5 minus 1. And the world is a happier place. Hit the smiley face button if you agree with me and you saw the error that I made. Are you with me? All right. You know, even teachers need to be a bit neater sometimes as well, I think. I think that's the lesson, isn't it? That's the lesson we take away. All right. Let us continue our journey. This was submitted by a student to the questions for the week idea. Okay, we're not going to have time to do this, but I think in the next lesson I will come back to that. So let's rather carry on going. Although maybe that's going to be a bit much. Okay, I want to do this question over here. So this is a combo question for the reduction formula and kind of some of the questions we've been doing tonight. we have to take, it says, if sine of 17 is a, without using a calculator, express the following in terms of a. What is the most important step I need to do? It says without a calculator. What am I going to have to do to help me evaluate this? Tell me in the chat, what is the key idea that I'm going to have to do to evaluate this? If I'm not allowed to use a calculator, the only way I can get it is going to be with a drawing. But there's no mention of quadrants here. So if there's no mention of quadrants, what you do is you just draw a freestanding triangle where you have a 17 in it. So you have a right angle and a 17 because there's no mention of quadrants. Give me a thumbs up if you understand why I have to start drawing a triangle now, because there's no mention of quadrants and they said it's without a calculator. Okay, now my next step. I've got a problem. I need two sides here before I can get the third side with Pythagoras. Can you tell me how I can get two sides out of this piece of information here? So the sneaky thing that we always have to remember is that a can be written as a over 1. And that's useful because we know the sign of something is the same as O over H. So if I go to my triangle, this is going to be little a, okay, over here. The H is going to be 1. Because the sign is over H, but this is also A, which is A over 1. Give me a thumbs up if you followed that idea. I've used this trick before where I rewrite it as A over 1 to get two sides. Now you're going to have to get me this side over here in terms of little a. So just to use that would be big H, that would be big O, that would be big A. What is that side over there going to be in terms of A? You use Pythagoras. What do you start with doing? So we'll say 1 squared is equal to a squared, and then I'll just say big A squared. Then I'm going to say 1 minus a squared. So I'm going to say that this thing over here is 1 minus a squared square rooted. Give me a thumbs up if you follow how I got. Oh, I must acknowledge the tool that I've been using. Give me a thumbs up if you understand how I got this. Thumbs down if I lost you. Yeah. Renew has raised a hand. I think you were just agreeing with me. Hey, Renew, or do you have a question?
So I have a question.
Oh, no, let's go and do that. That's much better, yeah.
In terms of Pythag, since we are given that a is equals to sine 17, is it wrong if we say sine 17 like you add it into the Pythagoras equation?
Yeah, because it says because you can't really use that without a calculator. So, I mean, where would you put it? Does that make sense? Like in A. Yeah, I don't think that's not the traditional way that we would answer it. I'm struggling to think of exactly what you mean, but generally speaking, if they say without a calculator, you basically need a drawing, and then you translate into two sides, find the third side with Pythagoras, and now we go back and try and figure this out. Okay. So now, what is the tan of 17? Remember, there's no calculators, but we have to use this. It's going to be something over something. What's it going to be? Well, we know that tan is O over A. Okay, so in this case, it's going to be A over the square root of 1 minus A squared, because these represent big O and big A. So I'm just pulling from this. So O is here. Big A is here. Okay, now that is the tan of 17. What about the sine of 107? Now we have to, I think there is no 107 in here. I could figure out that angle. What would that angle be? It would be 180 minus 17 minus 90. So I can get that this angle is 73, but that still is not 107. So I'm going to need another tool. Who can help me? What do I need to do to sine 107? Please, can someone in the class help me out? Share your knowledge. Wasile, Ganlon, Tandiwe, do you have any ideas? There's two ways we could do it. I'm curious to know which way you guys would choose. So if you use co-ratios, 107 is in this quadrant. And you could write the sine of 107 as sine of 90 plus 27. Sorry, 90 plus 17. And then you could say in that quadrant, sine is positive. And because we're using the vertical, this changes to the cos of 17. Or you could say the sine of 107 is the same as the sine of 180 minus 73. And in that quadrant, it's positive, so it's positive sine 73. Either of those are fine. So you can either evaluate cos 17 or you can evaluate the sine of 73. What is the answer I'm going to get for that using my triangle? If I'm using the sine of 73, I go opposite the 73. So I go 1 minus a squared, and the h would be 1. If I was using 17 and I was using cos, I would be the a, so that would be 1 minus a squared, and then h would be the 1. So both of these give you the same answer. Thumbs up if you followed that, thumbs down if you didn't. Okay, fantastic. Okay, let's do 5.2.3. I'll give you a tip. You need to reduce these things. So you go ahead and you tell me when you finished reducing them. I'll give you some time. I want you to reduce, and then once you've reduced, I want you to look at the triangle. So can I ask, why did you use cos 17 on 5.2.2? Okay, the reason I did was I was just trying to show you, I wanted to get in an extra example of using co-ratios. So Pafunzo, in some ways, I was just trying to show you how to do it. The other reason I did it was I wanted to get a 17 because there was a 17 in the first part. So if I hadn't already shown you that 73 was also in the triangle, you wouldn't have known that the sine of 73, or maybe you would have, but so it was just, that was the main reason. Does that make sense, Pafunzo? Awesome. Thank you for your question. Okay, so with this next bit, the cos of 253 is actually the same as the cos of 180 plus 73. Now I have to also square it, but that's me just rewriting it. Then the plus sine part can be written as, now 540 is actually the nearest horizontal, so 540 plus 17, and then it's squared. Now, ultimately, what you need to realize is in this quadrant, cos is negative. So this will be negative cos 73, and then that whole thing will be squared. And here, where is sine? Sine will also be, so it'll be plus, and then this will be negative sine 17 squared. Now, what happens when you square something is the negatives will go away. So actually, you're going to get cos 73 squared plus sine. I saw some unhappy faces there. So let me show you what I'm doing. 253 is just this angle. All this is showing you is that this last little bit is just 73 degrees. That's why, and it's in this quadrant, cos is negative. That's why it's minus cos 73. For 557, I basically went all the way to 360, and then I went 450, 540, and then a little bit past, which gives me the 17 there. But I'm still negative for sine in that quadrant. Then because I'm squaring it, negative times a negative is a positive. So that's why I've got positives. Now I've got one more problem. Unfortunately, these don't match. I would really love them to match. Is there a way I can get these two angles to match? What am I going to have to use? What am I going to have to use? I think I can change the cos of 73. So let me make some space. I think the cos of 73 can be written as the cos of 90 minus 73. Sorry, the cos of 90 minus 17. Better watch myself. And so that is reducing off the nearest vertical. And so the co-ratio of cos is sine, and it's in quadrant 1, so it's positive. So this, if that can be written like this can be written as sine squared 17 plus sine squared 17. Actually, you know what? For a lot of you, that might be overkill. But anyway, let's just say I did that. So now I've got 2 sine squared 17, which is 2. And now all I want to do is get what is the sine of 17. And the sine of 17 would just be what this thing is over here. It would be A. So that's the O. And then H would be 1. So it's 2A squared. So can we change the cos squared to sine? Yes, you can. That would give you exactly the same answer. So it's been asked, can we rather change the cos? Oh, that's what I did. Okay, that's a tough one to finish with, but I just want to go over what we've done tonight. So we've gone over the general trig questions, right? So if we look back here, we did some revision of general theory. We spoke about the quadrants. We then, earlier in the lesson, we spoke a little bit about equations. We then spoke about knowing where the sides are. We spoke about quadrants and angles. And then we spoke about these Pythagorean questions that often come up as the first question in trig. And we did some hard ones there. I'm not going to joke, like we did some hard ones. What are we going to do in the next lesson? So we're going to do more trig in the next lesson. We're going to do a few more reduction formula questions. We've done enough of these, so that we've done already. I'm also going to look at the identities. So we haven't done too many identity questions, so we need to do some of those. And then I'm also going to look at solving trig equations. So that's what's coming up, and slightly harder ones, like that's a harder one. So that's what we're going to do on Wednesday. Okay, everyone, let me know out of 10, how much did this lesson help you with trig? And then I'm going to dismiss class for today. Did you feel like you got a 5 out of 10, a 2 out of 10, a 7? I know this is tough stuff, so you know we're going for the real deal here. But if you go home and practice, the other thing is, remember that all our past lessons are on our YouTube channel. So if you want to go back and have a look at trig, let me actually just show you how to do that. So before you go, I'm going to bring up the MathsLive YouTube channel so that you can see it, and we will navigate together to see how we can find. Let's say you want to top up your understanding of so see Chrome tab, MathsLive. Okay, so I am on the YouTube channel for MathsLive. Now, obviously, I don't want to look at wait. I don't want to look at any old grade. I want to look at your grade. So grade 3, grade 11, term 3, let's have a look. So if I go back, number patterns, probabilities, stats, solutions to triangles. Okay, trig functions. I need to go back to term 1 and 2. So let's go back here. We go to playlists and we look at measurement. Let's look for grade. You know what I'm going to do? I'm actually going to just put 11 trig. And here we go. So trig equations, trig fundamentals, grade 11 trig that Sam did, identities and reduction formula, trig equations, the basics. So all these lessons are available to you on trig. Give me a thumbs up if you know where to find the lessons in case you want to go back and do some quality time with trig. Okay. And remember, you can watch these things on double speed. Hey? It's not like you have to watch them. YouTube has a speed setting.